The time and distance fields of each plane exist relative to a squared velocity comparison, which means perspective is rotating around each field defined as field spin. Each quadrant field has a field spin. The union field is also defined by a perspective rotation and has a field spin. The union plane has an exterior and an interior perspective with opposing spins. The spin of the plane is relative to the numbers that define it. If the spin from 1 is up, then the spin from the square root of 2 is down. Given that the plane is equalized and divided between 1 and the square root of 2, and given that 1 and the square root of 2 are not co-perceptible, then only half of the plane will be visible at any given time, which means only half of the spin will be visible at any given time. The fundamental pair of numbers 1 and the square root of 2 divide spacetime by their identity vectors. All spacetime is then relative to these two vectors, which means all other numbers and vectors will be perceived according to a relative angular rotation. The first number to come into existence that is not an identity of 1 or the square root of 2 is the number 3. Because any new number is relative to the spacetime from which it proceeds, then the number 3 will have four orientations, a number and a fraction for time, and a number and a fraction for distance. The relative helix, or equalized sine wave position of the number 3, is within the field of 2 times the square root of 2, which means the number 3 will be defined by 2 times the square root of 2 as an inversion mass node. The number 3 is an inverse-oriented vector, which means it has the same orientation as the reference 1 vector. The number 3 will contain all of the properties of 1 and 2, which means it will have an identity series of 3 times 2 to the nth power, and it will have its own power series of 3 to the nth power. The 3 to the nth power series defines a vector transformation wave that changes identity every multiple of 3. As the identity wave and the 3 to the n power wave begin to progress, the node positions begin to deviate, and the vector orientations begin to deviate. At the 12th multiple of 3, the node of the wave approximately aligns with the node of the 19th multiple of 2, and both vectors have the same up orientation as the reference 1 vector. This means that the vector power series completes a circle relative to the number 1 identity series, which defines a new and fundamental ordering of spacetime. The spacetime number set spans a range of 3 to the 307th power for numbers and the same for fractions. If the helix is viewed from the end, like looking at the end of a pipe, all the numbers will fall in their respective vector positions relative to the reference identity wave between 1 and 2. The same effect can be accomplished through identity reduction, or divisions by 2 for numbers and multiplication by 2 for fractions. For example, 3 to the 4th power is 81, and 2 to the 6th power is 64. 81 divided by 64 is 1.265, which is an identity of 81. 1.265 is located between 1 and 2. The 12 vectors that complete the 3 to the nth power vector circle are fundamental because the circle they complete is fundamental. It is important then to know their positions in the reference identity range between 1 and 2. This is accomplished through identity reduction. Given that the vector circle is referenced to equalized spacetime, then the 12 reference vectors are also equalized, resulting in the 12th root of 2 power series. On the 12th root of 2 power series circle, every other vector is inverted. On the 3 to the nth power circle, all the vectors align, but originate on alternating sides of the circle. The relative ordering of the space-time field by numbers ultimately leads to the defining of number fields and field limits. The circles formed from the 19th multiple of 2 and the 12th multiple of 3 do not exactly align. Given that both circles are fundamental to the structure of space-time, then the deviation between them is also fundamental to space-time perception. For historical reference, the vector deviation is most commonly known as the Pythagorean comma. If 12 vectors define a complete circle rotation, then one vector defines 1/12 of a circle rotation. The rotation between 2 and 3 is then defined as a single vector rotation. If a single vector rotation is divided by 100%, then the midpoint or amplitude of the wave is defined by 50%, and the quarter points or transition points of the wave are defined by a 25% deviation. Given that the node is a mass node and the amplitude is an energy node, then the transition positions between them are neutral. The maximum field perception of the number 2 vector, and by extension any number vector, is then 25% of a vector rotation. The vector deviation is 3 to the 12th power divided by 2 to the 19th power, which equals 1.01364. This number defines an approximate 23.5% vector rotation, which is within the maximum field limit of 25%. Given that the vector deviation is fundamental to space-time perception, and that it is defined relative to equalized space-time, then the vector deviation must be equalized. The equalized vector deviation is defined by a 24% vector rotation. Given that each of the 12 vectors that form the vector deviation are fundamental, then the 2% vector deviation that each vector contributes is also fundamental to space-time perception. The number vector field is then defined by 12 microdeviations, with a 13th neutral position separating opposing fields. Each vector field is then divided by an energy amplitude or antivector at the 50% rotation, with transition positions at 25% rotation. The energy amplitude position is defined as an antivector because, from a mass perspective, it is not perceptible, but from an energy perspective, it is perceptible. The equalized field is then divided by 12 vectors and 12 antivectors, with the midpoint between vectors and antivectors defined by a neutral transition state.